Hello everyone, we're looking at question 5 of summer 2019, paper 1 to 9702. The question reads, a student wishes to determine the density of lead. She measures the mass and diameter of a small sphere of lead. We have the mass, we have the diameter with their uncertainties given. What is the best estimate of the percentage uncertainty in her calculated value of rho? Now, there are a few points that I would like us to remember whenever we're dealing with uncertainties. Number one is when two things are being added or subtracted, their uncertainties will always add up. Number one. Number 2 point is when two things are being divided or multiplied, their percentage uncertainties will always add up. And number 3, whenever you have a power, you multiply your answer with the power. When you have a power, you multiply your answer with that power. And number 4, you ignore the units. Now, you will better understand them once I start doing this question. So we have to find the density. And we know that density is equals to mass divided by volume. When we know that density is equals to mass over volume, we know two things are being divided, which means that once we find the percentage uncertainties, we can simply add them up and you will get the answer. Now the question here arises is, number 1, how will we find the percentage uncertainty? And number 2, we have to find the volume what they have given as a diameter. Let's deal with the first problem. The first problem is how to find the percentage uncertainty. Simply, all you have to do is you have to take this uncertainty 0.005 and then you just simply divide it by the value 0.506 and then you multiply it with 100. Let me see what colors we have. Okay. And we will be doing the same for this as well, but we have to find the volume and not the diameter. How do we find the volume? We know it's a small sphere and we know the volume of a sphere is equals to 4 by 3 into pi into r cube. Now they have given us a diameter, we have to find the radius from there. So how do we find the radius from the diameter? You simply divide this by 2. So what we will be doing is 0.02 divided by 2 is 0.01. You divide that by 2.2 divided by 2, which is 1.1, and simply you multiply that with 100 as well. Now this is not where it ends. We know this radius is raised to the power 3. So when you have it raised to the power 3, this point says when you have a power, you multiply your answer with that power. So whatever answer you get, you're just supposed to multiply this with 3. Now you will get the percentage uncertainty. You're not to be concerned with the entire formula, not anything of that sort. You're just dealing with the uncertainty. Now when you put this in calculator, 0.005 divided by 0.506 multiplied by 100, answer plus 0.01 divided by 1.1 into 100 into 3, you get a value of 3.7, and so your final answer is D. And when we say you ignore the units, if they had given us let's say they had given us since the reason why we're saying we have to ignore the units is because when you write 0.02 millimeter and then you divide it by 2.2 millimeter, the units are simply going to cut out, so you don't have to worry about the units. And this is it for question number 5.